I'm Beth LaCourse.
And I'm Jake LaCourse.
And we have two daughters, Reagan and Rebecca. Rebecca was born on January 20th, 2016, and we were absolutely thrilled. She completed our family. Rebecca was diagnosed with profound deafness when she was about 8 weeks old. And that was difficult. We thought that was a really big deal when we first got the diagnosis, but then a couple months later, once we got involved with the deaf community and we started learning sign language, we realized that deafness wasn't that big of a deal and it was easily overcome.
We realized it was Becca's normal, and that was something that we were just going to have to figure out how to navigate, and we're feeling pretty confident that we're going to be able to do that.
They know it is useful after all. Some play horns and some play ball.
Usher syndrome is a deaf-blindness syndrome. There are so far at least 10 genes, probably 12 genes, which are associated with Usher syndrome. There's lots of different mutations, and Usher syndrome is classified depending on the onset of the retinal degeneration and deafness, and also the severity of the symptoms. So it's classified as Usher 1, Usher 2, Usher 3, Usher 1 being the one that's considered the most severe in the sense that the onset is much earlier on. Children who have Usher 1, Usher syndrome type 1, are born typically either fully deaf or very severely hearing impaired, and then they tend to have a fairly quick degeneration of the retina, which leads to blindness.
When Rebecca was 8 months old, we got the diagnosis of Usher syndrome type 1B. So we found out that is what was the cause of her deafness, her balance issues. She has profound bilateral vestibular loss, and would also be the cause of her vision loss. She already has some night vision loss and some peripheral vision loss. So at nighttime it's a little tricky for her, but during the day she does great. Her doctors expect that around somewhere between 10 and 12 years of age that there'll be a steep decline in her vision.
So it'll be more, and it'll start to close into that real, like you're looking through a straw over time.
And then by the time she's in her mid to late teens, they don't expect her to have very good usable vision. When we found out about Usher syndrome and the vision loss, that was a bigger hurdle for us to overcome. We're hoping that soon there's something that can help her where that won't happen, where she won't lose most of her vision.
Yeah, and then there's some work around reversal as well for vision.
After receiving the diagnosis and learning more about it, Beth and Jacob realized that not only would this be a challenge, it would be one that not many families ever have to face.
Usher syndrome is a significant unmet need. As you may be aware, it affects both the ear and the eye and the sense of balance. And so the patients who have Usher syndrome have significant challenges.
I realized that it only affected 20,000 people in the U.S. and in Becca's case, it's of her type, it was only 7,000. So you kind of feel like, there's not a lot of people thinking about how to cure this. So we realized right there that we're going to have to really, kind of figure it out on our own.
It took a long time. I mean, we're still trying to figure it out now. After figuring out that she had the Usher syndrome, I guess our next plan of action was trying to figure out what we could do to potentially slow down the progression of the vision loss, help her with her balance, help her more with her speech. She was in early intervention, so all of her services, or I should say most of her services, were through early intervention. She had hippotherapy, which is on a horse, to help with her balance. She had PT multiple times a week through early intervention and also up at Children's Hospital. She had a teacher of the deaf come out once or twice a week, speech pathologist come out once a week. She had a teacher of the visually impaired come out every other week. Auditory verbal therapists come out every week. Vestibular appointments up at Children's Hospital. Those are not too frequent, but she does have mappings every couple of months.
It's actually really important that she goes to school very young because it's, her, with the brain being so plastic, it's easy for her to learn right now. So when you think about trying to learn how to hear differently than you and I hear, it takes a lot of work. So she goes to a school that's, they specialize in exactly that. She meets with speech therapists constantly. She has sign language personnel there as well that help her learn sign. And of course the curriculum's all built around making sure that she's maximizing her cochlear implants. The school itself, even the setting has to be kind of acoustically accommodated for children with cochlear implants. And also because of her vision, they had teachers of the visually impaired come in, make sure that the school was set up properly so that she could navigate it safely. So things like tape on all the transitions, making sure that the playground was safe for her. All of that you have to take into account when you're bringing a child with extra needs through school. All stuff we had no idea that was. With Reagan, our older daughter, it was, is sent into school, and but with Rebecca, there's quite a bit of extra things you got to think about. Focusing on what she'll need later in life. We started to see some of the challenges that she'll face, and tried to figure out how to help her. That was with sign language. It was. The cochlear implants obviously was a decision that we had to make.
She can hear with cochlear implants.
So a cochlear implant is an implantable device. So that inside Rebecca's skull is a device that accepts a signal that transmits a signal to an electrode that stimulates her auditory nerve.
Hey, hi,
Rebecca.
On the outside is like it almost resembles a hearing aid where there's a microphone and then a magnetic piece that connects the internal piece to the external piece. When they do come off, she's completely deaf.
But sometimes she prefers not to wear them. Like this morning, I don't think she wanted them on until about 11. So we were just signing until 11, and then once she wants them on, we put them on and she talks.
Cochlear implants that do a pretty good job of simulating sound. The vision is quite a bit different. The amount of information that you take in from your eyes is quite a bit. It's exponentially more than your hearing. So it's hard to create a electronic device to be able to simulate vision.
A major focus used to help Usher syndrome patients is through a research method called gene therapy.
So there's lots of different approaches that can be used for gene therapy. So the work that I personally did was to replace a gene that's non-functional. But there's a lot of different ways. So you can think about, first of all, why the gene is non-functional. So you have to know what the mutation is. So we have ways to define that. And then once we know, we will want to know, is the gene not translated, which means is it not making the protein that is important for that function, or is it making a short protein that is not functional, or is it making a short protein that's maybe partially functional? So depending on what the mutation leads to, you might look at different approaches. So one is called gene replacement, where you basically provide the correct version of the gene and you get the protein expressed. So that's what I personally did looking at Usher syndrome type 1C. You can look at repairing the gene, which would be more of a long-term therapy, in the sense that you repair the gene in the cell and it's corrected forever. There's different approaches, and a lot of the work that's done now by different labs in Boston is to really do that. So it's using new technologies that can allow you to go and really just cut out a little piece of the gene, replace with the correct version of the gene, and then just let it be. So that would be gene repair. And you also can use different tools that can modify the expression of that gene. So you can use several platform, oligonucleotides, for example, is one of them. So you just can think about gene therapy as a way to repair the gene or provide the correct version of the gene.
For the work we're doing, we're focused on the inner ear. And the inner ear we think is a good model for this because it's a small enclosed space. But the strategy could eventually be used on any of a number of different inherited genetic diseases. Once we show that it's safe and effective in the ear, we might be able to move to other organs or tissues and treat any of a number of different genetic diseases. So I think having this gene delivery platform is going to be important, and then expanding, building on some small initial successes, we may be able to target a broad range of genetic disorders.
My guess is there's definitely going to be options for patients. My guess is it's going to be first targeting the retina because there's already been a clinical trial approved, not for Usher syndrome, but for a retinal degeneration, which is somehow similar to what the patients with Usher syndrome have. And so I think because that clinical trial was successfully conducted and led to new drugs, viral-based drugs that are, gene therapy drugs for retinal degeneration, I think probably that's going to be the first treatment that will become available for Usher patients.
We want to get this into humans, and we'd like to start clinical trials within 3 to 5 years. There are at least 100 different forms of genetic hearing loss, and so we're starting with a few of those where we think we'll have some success, but we'd like to be able to expand to some of the others, and maybe eventually we'll have a precision medicine approach where we could target any of these different forms of genetic hearing loss. So I could imagine a future where a patient comes in with a hearing loss, they get a genetic diagnosis, and then we could design the perfect therapeutic to inject into their ear to restore function. So there are several groups around Boston and around the world who are focused on Usher syndrome, and so it's great to see this emergence of interest in gene therapy and in Usher syndrome. And so a few different strategies are being attempted. One is the strategy I just talked about, a gene therapy strategy, but there are a few others that are making progress as well. And it's I think too early to tell exactly which one will be most successful in the clinic, but a number are moving in this direction, so I'm optimistic.
It's really important that people, more people know about it, so other people that are wondering why their child might have balance issues, start to put the pieces together and can find out that their kid also has Usher syndrome. That the more people that actually are out there that have it, the better chances that there could be a cure as well, because there's more people for the doctors to study.
Until doctors are able to find a cure, Jacob has taken his background in engineering and product development to create new devices in order to help Rebecca succeed.
The lighting on the stairs, that is something that we're working on to help Rebecca navigate the stairs a little bit more safely. And also I have a cane training device that I'm working on as well. That's a prototype right now. But what it does is that, when you give a 3-year-old a white cane, they just want to go and hit everyone with it, right? So what we did was we created a device that actually will know when the cane is brought up to a certain level, and it lights up and it kind of makes some cool sounds to sort of get them to hold it at the right angle. Just simple ideas like that could hopefully help her learn how to use these tools that she's going to need. And then, of course, the Becca is a Braille teaching device that's it's about the size of a laptop, and what it does is you can take little toys, put an NFC tag on them, and that little NFC tag can be read by the reader, and it pops up the corresponding word on the device. The reason why we did that, or I did that, was Beth had gone to a conference, and she saw that it was actually for products for blind people, and when she didn't see a lot of things for kids. I wanted to create this cool interactive device that would help the teacher Braille, and also would help other kids maybe interact with her as well. And again, it was for Becca, and then when we realized that it could have impact for other children as well, then we started to realize that we could keep moving it forward and hopefully impact the lives of other children and families as well. Adapt the World Labs, and it's a 501c3 not-for-profit company that we're gonna use to help create more products and be able to give those out to people that might need them, to just enhance their lives a little bit. Help with and to be able to show that the technology that's being developed today isn't just useful for typical people, it's also useful for people that have extra needs as well.
We deal with it by trying to raise awareness and raising funds for a cure. What helped us a lot was all of her services, her early intervention, her physical therapist, her teacher of the deaf, her speech therapist. So many people came together and helped us learn how to challenge her and how to help her.
It's sort of we want her to be independent. I mean, there's a whole side of when you do have extra needs, there is a piece of interdependency that you have to rely on, and you do have to rely on people to help you. But we want to try to make her world. We want to have her be as independent as possible, and so that's sort of what we're trying to do, is provide her those tools, all the stuff that Beth does with the appointments and the therapy and getting her prepared so that she can communicate effectively later on in life is super important now, and that's sort of what we as a family do now.